Good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. When you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. Today we're starting chapter 9. So we're going to look at section 9.1 today. So let's get going. All righty. If up until now you haven't been using a calculator, you will definitely need it in this chapter because we're going to be taking some like square roots or cube roots of numbers that aren't nice, and then you'll have to round them to the nearest 10th or 100th or 1000th or whatever. So if you haven't been using a calculator, you're going to want to have one handy for this chapter. Okay, so first of all, I just want to talk about roots. So who wants to volunteer? It's an easy question.
Sure.
Okay, Diana, if I said, tell me about your roots, am I asking about your hair? What am I typically asking about?
Like where we're from?
Where you're from, so where you began, your beginnings, right? Okay, so let's say I take the number 3 and I square it, I get the number 9. Okay, now 9 is a square, right? It's a perfect square. What are its roots? Where did it come from? It came from 3 being squared. So if I want to take its square root, I'm saying let's go back to the number we squared, which would be 3. Does that make any sense?
Yes.
So
Yes.
Squaring it, we're raising it to a power. Unsquaring it, we're taking the square root of it. We're going back to where we came from. So like addition and subtraction are sort of inverse operations, multiplication and division, inverse operations, exponents and roots, inverse operations. All right. Likewise, if we take 2 and we cube it, we get 8. If we take the cube root of 8, we say, what was it before we cubed it? We get back to 2. All righty. Now, let's talk about vocabulary. The cube root of 8. This number right here is called the radicand. Okay. This symbol right here, it's a grouping symbol, is called the radical. And this number up here is called the index. The index tells you what root you are taking. The radical is a grouping symbol, so it says we're going to deal with everything inside the grouping symbol before we deal with other stuff outside. And the quantity that's inside is called the radicand. So the index is a 3, the radicand is an 8 for this example. Okay. Now, there's no index written for this problem. Since the square root or second root is the most common root taken, mathematicians who are lazy, I mean efficient, tend to not bother to put a 2 there. So if there's no index, it's an implied 2. Okay, and what is the square root of 4? It's also 2. Lots of 2's there. All right, so you've got the index, the radical, the radicand. Any questions about that before we go on?
Nope.
All righty. What is the square root of 49?
7.
7. What is negative the square root of 49?
7.
What?
Is it 7?
It would be negative 7, because that negative sign outside would get attached to whatever comes out.
Okay.
You following that okay?
Yes.
All right. What's the square root of negative 49?
7.
Well, if that's true, then that means 7 squared equals negative 49, does it?
Negative 7?
Well, does negative 7 squared equal negative 49?
Well, if a negative, because negative 49 squared means two numbers multiplying each other. So would it be no solution?
Yes. There's no real solution. Okay. And this leads to our first big rule. You can't take an even root of a negative number. So the index can't be a 2, 4, 6, 8, 10, 12, whatever, if the radicand is negative. You can't take an even root of a negative number. All right? Make note of that. That's going to be important throughout this chapter. Now, what does 3 squared equal?
9.
What does negative 3, the quantity squared, equal?
9.
Good. What's the square root of 9?
3.
What's the square root of 9? Wait, I'm not even going to make you answer. When we take an even root of a number, we only get the positive root. Even though negative 3, the quantity squared, is 9, going back the other direction, we get what is known as the principal square root. Okay, and if you take the square root of 9 on your calculator, it only gives you the positive 3. This is our second big rule. When you take an even root, you can't get a negative answer. Okay, now these first two rules, the key words there are even and negative. You can't take an even root of a negative number and get a real answer. When you take an even root of a positive number, you can't get a negative answer. So if the index is even, this can't be negative, and the answer can't be negative. Okay? All right. Calculator time. We want to find the square root of 340. Now, if you have the TI-30, what is it, X, Roman numeral 2S kind of thing that was in the syllabus, on your calculator over here on the left column, there is a square root symbol, and I believe it is a second function of x squared. Be careful, because there's also a symbol that has a little x in the index. That's not the one you want if you're taking a square root. Okay, so if you have a calculator handy, take the square root of 340. If you don't, then later on you can do that. And the directions say give the answer to 4 decimal places. So I'm getting 18.43908891. The 4th decimal place would be right there. The 5th place, the 8 would round up. So I'm going to get 18.4391. Okay, and technically this is approximate, but they're saying to round it to 4 places. Any questions on that?
So I'm using, I don't know which one I have, Mr. Mayo, but
Okay.
I plugged it in and it gave me 2 with the square root of 85.
Okay, all right. So your calculator is set up in a certain mode. And actually, here's what I'm going to do. Danielle, was that you?
Yes.
Yeah, okay.
Mine is the same thing.
Same thing. Okay, let's deal with it. I'm trying to think about this just a second. Let me find the old calculator. Where did I put that? Here it is. Here it is. Okay. Okay. So let's see. There's a button. Trying to remember. I think it's right up here, and there's a button that says DRG. Right here is the second button, and then right here there's a button that says DRG. Is that true on your calculators?
No, I don't have any DRG.
Okay.
I have mode right next to the second.
Okay. You got mode. Okay, great. So is mode the first button, or is it the second function of that button?
It's the first function.
First button. Okay, push that button. What does it say? What options does it give you?
DEG, rad, GRAD, and norm, science, or sci, and English, I think, and float, and classic, and math.
Choose classic. Now go back and take the square root of 340 and see what happens.
Okay, yeah, 18.4.
Okay, super. So on the mode button, yeah, and so I don't have any of those calculators at home. They're all in my classroom, and I went back to get one when this whole thing happened, and I couldn't get into my classroom, and I'm too cheap to go buy another one. So I stumbled through it. So here we go. Okay. Also, did I start to record this thing?
Yes, it says recording.
Okay, good. So the whole world will now know that I'm cheap. All right. Anyway, you got that figured out there? So you want it on classic mode. Okay, excellent. Now, let's go on. And, okay. The square root of 64t squared. The directions say, simplify each expression, assume that all variables are unrestricted, and use absolute value symbols when necessary. Well, in fact, you know what? Let's work our way up to this. Let's come back to that. Let's just start with the square root of 3 squared. What would the square root of 3 squared be? Nobody has any idea?
3.
3, right. Now, the long way would be to do that, right? But the short way would be to say, oh, that index and that exponent sort of undo each other, okay? So the square root of 3 squared would be 3. All right, careful. What's the square root of -3, the quantity squared?
It would be no or not real, right?
Order of operations, what would we do first? You'd square it first, wouldn't you?
Yeah, and you'd get -9, right?
Careful.
+9, never mind.
Right, there you go. So I get 3, right?
Yes.
So here I got the base. Here I didn't get the base. I want to go back and do this one again. Is that true?
No.
Is that true?
Yes.
Okay, now let's see if we can take that short leap of faith. Suppose I said x as a variable is unrestricted. It could be positive, it could be negative, it could be 0. We don't know what it is. It could be any real number. Then I would have to do this. Because otherwise, what if x is negative? What if it's like this problem here? where I'm squaring -3, okay, and then I wrote the answer as -3, no, that wouldn't be true. So because I don't know whether x is positive or negative, these absolute value bars assure me that I'm not getting a negative answer, because remember, when you take an even root, you can't get a negative answer. All right,
Yeah.
let's see if we can wrap our heads around that. Let's go back to this problem now. Same thing. Assume the variable is unrestricted. So it could be positive or negative or 0. All right, so what's the square root of 64?
8.
What's the square root of t squared?
T.
But what do I need to do?
Put the absolute value
Around what?
around the. Would it just be the T or both the 8 and T?
Just the t. You don't need
Oh.
it on the 8, because 8 is 8. We know that 8 is positive, but we don't know what t is. Okay. Besides that, drink those British people eat, but drink whatever. But okay. You all right with that?
Yes.
Now, this is where I get to be mean and evil, because just when you think you've got it figured out, I'm going to throw you a curve. So let's see what happens. So be careful. What's the square root of 36?
6.
6.
What's the square root of y to the 4th power?
Y squared.
All right. Do I need absolute value bars here? And if so, around what?
Would it be just the y?
It'd be over Y squared, right?
Nope, we don't need them. Why not? Because if y is negative, but you're squaring it, it's going to make it positive. So there's no way that could represent a negative answer, because you're squaring y. You see it? Let's put some numbers in there. Let's just say that y is -2. That would be positive, because squaring, if y was negative and you squared it, it would still be positive. So I don't need any absolute value stuff there, because there's no way that answer can be negative. If y is negative and you're taking a negative times itself, it becomes positive.
Okay, I get it now.
All right. Here we go again. The square root of 9y to the 6th power. Again, assume variables could be any real number, no restrictions. So what's the square root of 9?
3.
What's the square root of y to the 6th?
Y cubed.
Okay, how about here? Do I need it here or not?
Yes.
Why?
Because if you square it,
Cube.
If you cube it. Wait, go ahead. Sorry, my bad.
well, I was going to say if you square it, if you were to square 2 negatives, you get a positive, but that isn't to say the other is going to be negative. I don't know.
But we're not squaring it here, we're cubing it. In other
Right.
words, yeah, so this,
Depending on what y is, if you're going to multiply it by a negative, it's going to come out negative on that third cube.
yes. Now I think we're on the same page there. So I need them here.
Yeah.
Okay. How about this one? What's the square root of 4?
2.
What's the square root of n to the 8th power?
N to the 4th power.
How about here? Do we need absolute value bars here?
No,
Why not?
because if you were to square it by 4, it's gonna.
Wait, you
Even
raise it
out.
to the 4th power. You wouldn't square it. So yeah. Okay.
Oh yeah,
So-
sorry, raise it to the 4th. It's
Yeah.
gonna cancel out those negatives if there is some.
Right. Good job. Okay. Okay. How about this? Now, the mistake here is to assume that we can take a sum or a difference and break it up and write it like this. Can't do that. Okay, and we'll learn more about that later. But what we can do is write this like that. Isn't that a perfect square trinomial? Oh no, not factoring again. Okay. You see how I got there?
Yes.
So now what's the square root of that? Do I need absolute value bars around that or not?
No.
Yes, I do, because b could be negative. In fact, if b is anything less than 7, we'd have a negative answer.
Oh, that's right. Yeah.
Okay. I know, I'm just keep messing with you here. How about this?
I have a question, Mr. Mayo, on that last one.
Mhm.
Oh, now I see it. I was wondering, it didn't process through my head when you said anything less than 7, but yes, makes sense now. Okay.
Okay, okay, no problem. This is also a perfect square. Okay. So the square root of that would be this. Do I need absolute value bars here?
No,
Why not?
because anything squared is going to be positive, and then plus 5 is positive.
Right, positive or 0 and then plus 5. Right, but this would not be negative. Good, 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 good. All right. Let's see here. I am going to switch screens. So we're going to close this up and open up this screen, hopefully. And I'm going to do some graphing. Yeah, let's see, 5, 10, 5, 5. All right. It says complete each table, then graph the function. It says f of x equals the square root of x plus 2. Okay. Now, the x is inside the radical. The 2 is an afterthought. The 2 is not inside. So we're going to put a number in for x, take its square root, get the result, and then after that, add 2. Okay? Why do you think they chose 0, 1, 4, 9, and 16 for x values? What's true about all of them?
They are all perfect squares.
Right. And if you unsquare a perfect square, you get a nice number. So they deliberately didn't pick something like 0, 1, 2, 3, and 4. They picked numbers that would work out nicely. So f of 0 is the square root of 0 plus 2, which is 0 plus 2, which is 2. So far, so good?
Yep.
Okay. F of 1 equals the square root of 1 plus 2, which is 1 plus 2, which is 3. Okay?
Yeah, I'm good.
Okay. I'm just waiting. I don't want to bury you in the dust or whatever. Let's see, the f of 4 is the square root of 4 plus 2, which is 2 plus 2, which is 4. F of 9 is the square root of 9 plus 2, which is 3 plus 2, which is 5. And f of 16 is the square root of 16 plus 2, which is 4 plus 2, which is 6. And let's see, actually I can go all the way out here. And you can't see it. Let me move this thing out of the way. So can you see it now? So you get, so then it, you get this picture. It's going to continue on to the right, but it's going to stop at the left side there. Okay.
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 Now, what's the domain? Of this function?
Would it be all real numbers?
Can I put a negative number in there?
No.
So correct your answer. What would it be instead? Could I put 0 in there?
Yes.
Could I put any positive number in there?
Yes.
But I can't put a negative number in there, right?
No.
So it'd be from 0, including 0 up to infinity. Does that make sense?
Yeah.
Good, good. Okay, range. What's the lowest range value on the graph?
2.
Good. What's the highest range value if it continued on?
Infinity.
Good. So your domain is greater than or equal to 0. Your range is greater than or equal to 2. Okay with that?
Yes.
All right. We good to go on to another problem?
Yes.
Okay,
Yes.
go to the next page and let's make it a graph. -5, 10, -5, 5, 10, -5. All right. It says graph each function, give the domain and range. We're going to graph f of x equals the square root of x plus 4. Okay. Now, I go again, trying to walk and chew gum at the same time. If I just had the square root of x, I'd want to put in nice squares like 0, 1, 4, 9 to 16, right? But I don't have just the square root of x. I've got the square root of x plus 4. So I want x plus 4, that total quantity, to be a perfect square. I want x plus 4 to equal 0, x plus 4 to equal 1, x plus 4 to equal 4, x plus 4 to equal 9. How far away from x is this? It's 4 units away from x, isn't it?
Yes.
I'm going to take x and add 4 and then take the square root of it. So to achieve these numbers, I want to go backwards. I'm going to subtract 4 from each of these. And if you're not following this, hang on a second. Hopefully this will work. What's 0 minus 4?
-4.
What's 1 minus 4?
-3.
-3.
What's 4 minus 4?
0.
0.
What's 9 minus 4?
5.
What's 16 minus 4?
12.
Now, by taking these values and subtracting 4 and getting over here, now when I put these in here, the first thing I'm going to do is add 4 to them, right?
Yes.
So f of -4 equals the square root of -4 plus 4, which is the square root of 0, which is 0. Nice. F of -3 equals the square root of -3 plus 4, which is the square root of 1, which is 1. Nice. F of 0 is the square root of 0 plus 4, which is the square root of 4, which is 2. You thought I was going to say it, but I'm not going to say nice. Okay, you see what's happening though?
Yes.
By subtracting 4, and then we add 4, we get back to here, we get back to nice numbers. So now my graph, -4, 0, -3, 1, 0, 2, 5, 3, 12, 4. Okay. What's the domain?
Would it be -4 to infinity?
Bingo. Well done, young Padawan. You are ready to become a Jedi. What about the range?
Would it be +2?
Let me give you a hint. Why? And that's not a question.
0.
What?
Would it be 0,
Yes.
infinity?
Yeah, because we're looking out here, not there. Here's your lowest Y value right there. All right, now for the Jeopardy bonus example. Let's go back to, hang on, let's see here. And maybe, nah, forget it. I forgot about the +2 there, so that would just be confusing. So we're not gonna do what I was gonna do there. All right. Now I'm gonna go back to my other screen. Okay. F of x equals the square root of x plus 6. We are to find the domain. Now, let's review 2 big rules that I gave you at the beginning of this whole thing. The first thing I said, the first big rule was, you can't take an even root of a negative number. So if the index is even, the radicand cannot be negative. All right? Is the index even here?
Yes.
So the radicand cannot be, negative. Now, if it's not negative, what are the options that are left? Yeah, I'm trying to get this thing out of the way here. Well, it could be positive or equal to 0. So all I did was I took the radicand and said it's got to be greater than or equal to 0. It's got to either be a positive number or 0. It can't be negative. It's got to be non-negative. You see what I did there?
Yes.
So now let's solve for x. And let's write that in interval notation. So the domain is anything equal to or greater than -6. If x is -6, we get the square root of 0, which is 0. If x is larger than that, we get positive, and the square root of positive is positive. Okay?
Do you mind showing another example similar to that one?
Not at all. I was going to anyway, but I especially will because you asked. All right, how about this one? T of a equals the square root of 3a plus 17. Since I'm taking an even root, the radicand has to be positive or 0. So I take the stuff inside and set it greater than or equal to 0, and then solve it for the variable. So 3a greater than or equal to negative 17, divide by 3a greater than or equal to negative 17 thirds. So your domain, negative 17 thirds, included up to infinity. You okay with that?
Yes, thank you.
One more. G of x equals the square root of 8 minus 2x. We're taking an even root, so the radicand has to be greater than or equal to 0. Subtract 8, I get negative 2x greater than or equal to negative 8. But what happens when you divide both sides of an inequality by a negative number? You change the direction of the sign. So here the domain is up to and including 4. So here you could have all kinds of negative numbers because it's minus 2 times the negative number, which makes it positive inside. All righty?
Yes, so far so good.
So far, so good. Excellent. Okay. Suppose f of x equals the square root of 3x plus 1. F of 8 would be the square root of 3 times 8 plus 1, which is the square root of 24 plus 1, which is the square root of 25, which is 5, right? Questions there?
No, I'm just trying to copy down everything really
Yep,
fast.
no problem, no problem.
Okay, I'm done.
All right, let's find f of negative 2. That would be the square root of 3 times negative 2 plus 1, which would be the square root of negative 6 plus 1, which would be the square root of negative 5. Now, one of the things that bothers me about this book and about WebAssign is that sometimes they'll say this is undefined and sometimes they'll say it's not real, okay? And you'll have to basically look at the instructions in WebAssign to what options it gives you. Here, I would call it not real, but the book calls it undefined. And in WebAssign, I've seen it done both ways. So it'll give you the option it wants. So in other words, it'll say, you know, if it's not real or if it does not exist, write D and E. If it's undefined, write undefined. So it'll instruct you as to what option, okay? I guess I'll just cover my bases. All right, now, let's see here. How about the cube root of negative 27? What's that? Oh, wait, can we take an odd root of a negative number? Yes, we can. You just can't take an even root of a negative number. So what's the cube root of negative 27?
-3.
Yes. Oh, wait, can we get a negative answer? Yes, we can if we're taking an odd root. Those restrictions I laid out at the beginning have to do with even roots. You can't take an even root of a negative number. You can't get a negative answer when you take an even root. But with an odd root, yes, you can, yes, you can, yes, you can. Okay? So the odds are all good. What is it they said in the Hunger Games? May the odds be with you or something. I don't know. May the force be, wrong movie, sorry. Okay. How about this? The cube root of 125 over 64. We could separate that into the cube root of 125 over the cube root of 64. We could do it the fraction in pieces. What's the cube root of 125?
5.
Great. What's the cube root of 64?
4.
Good job. I'm curious, are you using your calculator or just figuring them out?
I use my calculator.
Okay.
I have a question. How do I input that in my calculator?
Okay. So there was a button that I talked about earlier. That's that.
Yes.
There should be another button, and it's typically on the button above it that has a little X in the index. You see that button?
Uh-huh.
Okay. For this, what you have to do is you have to put the index in first. So with the screen cleared out, there's nothing there except it's turned on. You're going to put in a 3. Then you're going to do the X root. And when you do that, I don't know if it puts a parentheses or not, but if it doesn't, put a left-hand parentheses. Then put in 125 divided by 64. Close up the parentheses and put an equals. And you're probably going to get 1.25 because it's going to give you a decimal answer instead of a fraction.
Okay, I found it now. Thank you.
Okay, you bet. You bet. Let's see, how much time have we got? Let's take a look at this. What's the 6th root of 64? No calculators this time. All right, let's figure it out. Could it be 1? What's 1 times 1 times 1 times 1 times 1 times 1?
6.
1. No, it's just
Oh,
1.
1. Sorry.
All right, okay, so how about 2? What's 2 times 2?
4.
Times 2.
8.
Times 2.
16.
Times 2.
32.
Times 2.
64.
Oh, so the 6th root of 64 would be the 6th root of 2 to the 6th. The index and the exponent wipe each other out and we get 2. How cool is that? Okay, fine. You don't think it's that cool. I'm sorry, I'm just a sick math nerd, so I think it's great. All
No,
right.
I'm still laughing at how you asked what 1 times 1 times 1 and I said 6.
It's okay, it's early, it's only Tuesday.
Yeah.
Okay. All righty. How about this? The 6th root of negative 729. You're working too hard. Think about the rules.
Is it because the index is positive we can't find?
Wait, the index, the index is always positive. The index starts with an E. Even.
Even. There we go.
That's why you can't take an even root of a negative number. So this is not real. Okay. So if you were sitting there trying to figure out what the number was, ha, I fooled you. I'm so mean. All right. How about this? The directions say, assume all variables are unrestricted. So t could be positive or negative or 0. What's the 8th root of t to the 8th?
T.
T.
Okay, just like that. Are we done or not?
You have to put the absolute value.
Yep, because what if t was negative 2? Then you'd basically be saying this. Oh, wait a minute. We'd have to do that to it, wouldn't we? Yeah. Okay. Let's see here. With this one. Assume all variables are unrestricted. Keep in mind, a radical symbol is a grouping symbol, so that negative sign is outside. It's like -1 times whatever we get out. Okay? We're to assume variables are unrestricted. So what's the square root of 144?
12.
What's the square root of t to the fourth power?
T squared.
Okay, and then this comes over here. But do we or do we not need absolute value bars? And if so, where? Careful. I laid a trap. I dug a pit. I covered it with leaves. I hung a Snickers bar on a rope. Will you take the bait? We don't need it. Why not? Because if t is negative, it's being squared, which makes it positive. Now, this has nothing to do with it because that's outside of the radical. It's this right here has to be positive, but then we apply that negative, okay? And t squared can't be negative because a real number, a negative times a negative is still going to be positive. So we don't need it there. I know. Is your brain hurting a little bit?
Yes.
Okay, hopefully not too much. All right, how about this one? So let's do this one. Square root of negative 64.
Eight, -8.
Can't do it.
Is that when you said it's going to be a 2 there?
Yep.
So you can't take a, okay.
Yep. How about this one?
-4.
Good job. You can take an even, excuse me, whoa, wrong. You can take an odd root of a negative number. You cannot take an even root of a negative number. Okay? I'm just going to keep pounding that away at you because that's a big deal. You got to get that. Okay. Let's see here. How about this? What's the cube root of 1000?
10.
Good. How about this one? Negative the fifth root of negative 243.
-3.
The final answer or just the inside part?
The final answer.
Oh, careful, because this would equal that. So then this would give you that. You see it, Greg?
Yeah, I see that.
Tricky stuff. I know. I'm so mean today. I just keep tricking you folks. Okay. You know what? I think I've tortured you enough. Don't you think I've tortured you enough?
I think we're okay.
You've had enough torture for one day. All right, we'll stop the